Welcome back to the Network Plus training series. This is the last objective in Domain 5, the tools lesson, knowing which tool to reach for, when, and what its output actually tells you. Master these, and you will solve problems faster than 90% of the people on your team. Objective 5.5. The appropriate tool or protocol to solve networking issues. 14 tools, 1 decision flow, and the muscle memory to reach for the right one before you even finish reading the ticket. Let's go. Start with the most fundamental tool, ping. Ping uses ICMP Echo Request and Echo Reply messages to test if a device is reachable. You send an Echo Request. The destination sends an Echo Reply. Round trip time gives you latency. Packet loss tells you reliability. If ping works, layer 3 connectivity is fine. If ping fails, could be the device is down, could be ICMP is blocked at a firewall, could be the route doesn't exist. Ping isn't proof of nothing, but it's the first thing you reach for. How ping actually works. Your machine sends an ICMP type 8 packet, Echo Request, to the destination. The destination responds with type 0, Echo Reply. Each request gets a sequence number so you can tell which replies match which request. Each request has a TTL value that decrements at every router. If TTL hits 0 before reaching the destination, you get time exceeded, useful for Traceroute, less so for ping. Traceroute, or Traceroute if you're on Windows, maps the path packets take from source to destination, hop by hop, sends packets with incrementally increasing TTL. TTL1 dies at the first router, which sends back a time-exceeded message that tells you the first hop. TTL2 dies at the second router, and so on until the destination is reached. Use it when ping fails and you need to know where the path breaks. The hop where you start seeing asterisks is usually the problem. DNS query tools. nslookup on Windows and Linux. Dig on Linux primarily. Both query DNS servers directly so you can verify name resolution. nslookup host name tests forward lookup. nslookup with a specific server tests against that server, not the system default. Useful when you're debugging which DNS server is broken. Configuration tools. ipconfig on Windows. ifconfig or IP on Linux. Show you IP address, subnet mask, default gateway, DNS servers, and MAC address. ipconfig/all gives you the full picture, including DHCP lease info. ipconfig/release and /renew force a new DHCP lease. First thing you try when a Windows client gets stuck. Netstat shows active connections, listening ports, and network statistics. Netstat-A shows everything. Netstat-N shows numeric addresses without trying to resolve names. Faster and avoids hangs when DNS is broken. Netstat-O shows the process ID for each connection. Invaluable when you're hunting what process opened that port. ARP, the protocol, the command, maps IP addresses to MAC addresses on the local network. RP-A shows the current cache. If you see two devices claiming the same IP with different MAC addresses, you've got ARP spoofing or a misconfiguration. Clear the cache with RP-D when you suspect stale entries. Pathping is Windows only and combines ping and Traceroute. First it maps the route, then it pings each hop for a while to calculate per hop packet loss and latency. Slower than Traceroute but tells you which hop is dropping packets, not just where the path stops. Nmap, the network scanner everyone reaches for. Discovers hosts on a network, identifies open ports and the services running behind them, detects operating systems and software versions, finds vulnerabilities, used for legitimate auditing, used for less legitimate scanning. Run nmap-sv on a target and you get a list of open ports plus best guess service versions, instant inventory, packet capture, 2 flavors, tcpdump, command line, fast, runs anywhere, capture on a specific interface, filter by host or port, write to a file for later analysis. Wireshark, graphical, beautiful, decodes thousands of protocols. Open the capture, click a packet, see every field decoded down to the byte. tcpdump for capturing in production. Wireshark for analyzing what you captured. Bandwidth testing. Iperf measures throughput between two endpoints. Run an Iperf server on one box, an Iperf client on another, and you get the actual usable throughput between them. Online speed testers measure your internet connection, useful but biased toward the test server's location and load. Iperf for internal links, online tests for the internet. Monitoring with SNMP, Simple Network Management Protocol. Devices expose performance and status data through object identifiers. SNMP walk retrieves a range of values. Monitoring platforms, Nagios, Zabbix, PRTG, poll devices on a schedule, store the history, and alert on thresholds. If you don't know your network's baseline, you don't know what broken looks like. SNMP is how you build the baseline. Now the part the exam loves. Tool selection. The user gives you a symptom. What tool do you reach for? I can't reach the server. Start with ping. If ping fails, traceroute to find where it breaks. I can resolve names but can't connect. Netstat for active connections, then a packet capture if needed. Everything is slow. Pathping to find the lossy hop. Iperf to measure bandwidth. I can't see this device. Nmap to confirm it's online. Strange duplicate IP warnings. ARP to verify the mapping. The right tool turns 4 hours of guessing into 4 minutes of confirming. Domain 5 review. We've been through it all. 5.1, the methodology. 5.2, cables. 5.3, wireless. 5.4, services. 5.5, tools. The whole troubleshooting playbook in one domain. That is Objective 5.5, and that is Domain 5. And that completes our coverage of all 5 domains for the Network Plus exam. You've got the methodology, the cabling knowledge, the wireless skills, the service awareness, and the toolkit. Go pass the exam, then come back and use this every day on the job. See you out there.